Ensemble Methods, CatBoost, XGBoost, and LightGBM in Python. Let's get started. These are winning algorithms in Kaggle competitions, and it's not a secret, these three techniques are so good with structured tabular data, and in this video I will break this free technique, but let's first dive into the big picture. Machine learning has several areas, and we have supervised learning that defines classification and regression. Then we have unsupervised learning that has clustering and dimensionality reduction. Then we have semi-supervised learning, reinforcement learning, and ensemble learning. Ensemble learning represents bagging, posting, and stacking. As you can see here, ensemble methods represents building potent models by combining weaker ones to improve the prediction performance. And most common practical use cases, such as loans prediction, prices forecasting, churning predictions. Basically, there are two terms when it comes to ensemble models. The first one is weak learner. The second one is a stronger learner. Weak learner represents simple model that performs slightly better than random chance with limited prediction accuracy prone to overfitting. Then we have a strong learner, models with a good prediction accuracy. Strong learner are a combination of multiple weak learner. In gradient posting, for an example, we aim to train a sequence of weak learners that approximate the gradient at each iteration. An example of gradient posting is XGBoost, which we will cover in the next slides. But first, it's important to highlight that bagging and posting are two types of ensemble learning that combines multiple weak learners to create a stronger learner or model. And when it comes to the ensemble learning types, we have parallel ensembles and sequential ensembles. Parallel ensembles meaning train each component Bayes estimator independently of the others, which means that they can be trained in parallel, as you can see in this graph. When it comes to the sequential ensemble, in the sequential ensembles, as in the XGBoost or CatBoost algorithms, each new tree can adapt and correct previous limitations caused by missing data or outliers, giving these models a real edge in handling messy real-world data. When the parallel ensembles, as in the random forest algorithm, for example, trees are trained independently and simultaneously on different bootstrapped samples. This makes them very efficient to train and naturally resistant to overfitting. The sequential ensembles, meaning training Bayes estimator to get the meta estimator, then use these results as a Bayes estimator to get the best performant model. 2 points I need to highlight it here. For prediction tasks, sequential ensembles, as in the gradient posting, that handles outliers and missing values because it's adaptive, meaning each tree corrects the last, but needs regularization to avoid overfitting. In parallel ensembles, bagging, aka random forest algorithm, it's great for reducing variance. Associated things I also wanted to highlight, whether it's a random forest, XGBoost, or CatBoost even, all of them work for regression and classification business problems. And that make ensemble models has a diverse edge because it improves overall performance and reducing overfitting. Heterogeneous ensembles, as in decision trees, supportive vector machines, and neural network, are trained on the same dataset, as in stacking or voting. On the other hand, homogeneous ensembles, the same algorithm trained on different bootstrapped datasets, as in random forest, a bagging method, or sequential method, as in CatBoost or XGBoost, with error correction. Add the post is also works because it's a posting method. Then we have the model aggregation. Ensemble models combine predictions from multiple models to create a final prediction. And that's completely true, as we can see here, in parallel ensembles or sequential ensembles. Bagging method aggregate results through majority voting, as in classification, or averaging, as in regression problems. Bagging methods aggregate results through majority voting for classification cases, or averaging for the regression cases. Posting method aggregate models sequentially, with new models focusing on correcting the errors of the previous ones and minimizing weighted error, whether it's adaptive posting, add a post, or gradient posting as in XGBoost. Stacking uses a meta estimator that learns how to optimally combine the prediction of base models. For prediction tasks, in classification models, combine predictions using a voting classifier, majority voting, hard voting, or weighted probabilities, soft voting. In regression models, combine predictions using averaging the predictions. Can be a simple mean, or weighted average. Moving on to CatBoost. CatBoost is actually represent categorical posting. It basically is a gradient posting algorithm to encode categorical data. Usually we don't need too much of feature engineering to classify the target variable. It holds two essential advantages. CatBoost divides a given dataset into random permutations and apply order posting on these random permutations. CatBoost smartly deals with categorical features using a new algorithm for processing categorical features by building new numerical features based on categorical features and their combinations. Remember, with the sparse datasets, LightGBM might outperform CatBoost. And for small datasets less than 50K instance, applying hyperparameter tuning and cross-validation can actually prove the performance of the CatBoost model. Simply to install CatBoost to your Jupyter notebook, type pip install CatBoost. We have XGBoost, or should we say Extreme Gradient Posting, is a powerful machine learning framework designed for building and deploying real-world machine learning problems. It's based on the principle of posting. It supports parallelization, making it higher scalable and suitable for large datasets. Additionally, it uses a level-wise tree growth strategy, which means it grows decision trees level by level, exploring various splits at each level to optimize model performance. In case you wonder the difference between level-wise tree growth strategy versus leaf-wise tree growth strategy, check this graph. Important to highlight that XGBoost should be considered in principle for any supervised problem that satisfies the following criteria. The number of rows is more than the number of columns. There are possible outliers in the input space. There is a mixture of categorical and numerical variables. In classification tasks, the target is imbalanced. To install XGBoost in Jupyter Notebook, simply type pip install XGBoost LightGBM. That stands for Light Gradient Posted Machines. It's basically a gradient posting framework designed for large datasets and high-dimensional features. It's based on leaf-wise tree growth strategy, which means choose the leaf with the maximum loss reduction to split next. Despite the promising accuracy of this LightGBM technique, the complex tree splits can jeopardize model performance, leading to overfitting. Don't forget that LightGBM is adaptive with categorical features when the t-type is category, not a string or object. Yeah, this is mistypo here. It should be object. To do that, to transfer or convert the d-type of variable of the columns in the dataset to category, so LightGBM can be trained effectively, simply apply this function, the def, the dataset name, parentheses, column name dot as type category. And to install LightGBM in Jupyter Notebook, simply type pip install LightGBM. And by the way, I also want to highlight that this image is from the blog code 360 LightGBM tutorial. I will add the source in the video description. Feel free to check it out. Then we have CatBoost and XGBoost and LightGBM are consistent to missing values, which means that we don't need to impute any value before fitting. However, each technique handles missing value differently. In missing values, if we impute them with zeros, like fill in a 0, usually XGBoost and LightGBM won't recognize them as missing value and may treat them as actual values, potentially hurting the model performance. For categorical features, make sure to specify them correctly so CatBoost can apply its native encoding. It's important to know which categorical variables are best suited for one-hot encoding, which categorical features encoding and which ones are more suitable with a different approach like embedding. Remember, we run comparisons to pick the best model. Aligning with these concepts, the Ensemble Methods concepts, and apply them in a business value context, there are four ingredients we need, or four terms we need to highlight: awareness, consideration, preference, and action. Awareness: define user need and evaluate the best method to satisfy his preferences. Consideration is a descriptive analysis. Do we have a benchmark to measure the success of our models? Is it a prediction analysis? What's expected from us here as a data scientist? Then we have preference. Best models gives the most relevant results. And action. What's your next step from the analysis, and is there any recommendation? With the small assignment for you. Try to Google these core techniques parameters, such as like learning rate, and check the XGBoost parameters, CatBoost, and LightGBM parameters. That's how you will get higher ranking score in Kaggle competitions. And next, I also wanted to help you by highlighting the essential parameters per model. But first, try to do this assignment before jumping to this part of the video. There are many essential parameters, and every technique handles parameters or has important parameters independently, but here I have combined all of them. Let's start with the learning rate. By default, in the XGBoost, it is 0.03. In the CatBoost, the same, LightGBM is 0.01. Then we have max depth, or the depth of the trees. Then we have poster and regulation, or L1. Then we have L2. Pause this video and read through them in more details. Let me know if you need any more clarification regarding this part in the video down below. That's it for today. Thanks so much for watching. If you find my content useful, like this video and follow for more. Bye.